All right, this is Mr. Wyrick. I'm here to talk to you about part 2 of the semester exam review. On this part, it's really just reducing radicals. It's all about square roots. Square root of 49 is 7, square root of 16 is 4, square root of 16 is 4 over the square root of 25 is 5. That's not really important as far as anything different. I take my exponent and I'm going to divide it by my index. Remember, if my index isn't like said to be something else, if something else isn't written in, it's a 2. So 10 divided by 2 is going to be 5. 8 divided by 2 is going to be 4. Hey, shh. Yeah. On this one, the m squared is just going to be an m. This is the important one. It doesn't reduce. So you have to kind of factor it back out. 32 is going to be 16 and 2. Square root of 16 is 4. So that's 4 on the outside. The 2 left inside. The thing that does not have a square root stays inside. 7 divided by 2, it's only going to go in evenly 3 times. We're going to have 1 left over. So this is what I end up with. Remember, multiple choice test. So you can assign numbers to these variables. And if you do that, then you can check decimal equivalents after you do square roots and be able to figure out which answer has the exact same decimal equivalent. On this one, if you're adding and subtracting, you simplify the radicals if you can, and then after that, you just put them together if they're like terms. Like this one doesn't look like terms, but the square root of 8 is 2 square root of 2. So this is 6 square root of 2 minus 2 square root of 2, which would be 4 square root of 2. These are not like terms. Nothing you can do to make them like terms. They stay like they are. You have to be careful on ones like this. This would be a negative 9 square root of 3x. This would be minus 3 square root of 3x. And then again, another negative 9 square root of 3x. When we put those all together, that's a negative 21 square root of 3x. That's just what it's going to stay. You only add the outsides. You treat this whole thing in here like it's going to be a variable. When you go to multiply and divide, outside times outside, inside times inside, and then reduce if you can. So on something like this, 3 times 4 is 12 on the outside, 4 times 2 is 8 on the inside. The 5th and 22nd would be the 27th, and I'm doing the cube root of this in here. Well, the cube root of 8 is 2. I already have a 12 on the outside. That multiplied by 2 is going to be 24. And the cube root of, z to the 27th, 27 divided by 3 is 9. That's z to the 9th. On the ones where it's fractional, it doesn't matter if it looks like this or if it looks like this. You divide if you can to make it easier. That would make this one g squared over 16. And when we do the square root of those, it's the square root of each part. So that's just g over 4. On 17, it's the same thing. 27 divided by 3 is 9. X to the 5th divided by x is x to the 4th. When we do the square root of that, it's 3x squared. So keep in mind that those looking different doesn't really make a difference. Again, you can find decimal equivalents using the calculator. With the back part of 2, 4x to the 2/3 would be still the 4 on the outside because the x is the only thing raised to the 2/3. That'd be the cube root of x squared. 7 squared of x would be 7 times x to the 1/2 power. And 5x to the 4/7. This one's finally like, this is in parentheses. This applies to both. It's the 7th root of 5x to the 4th. This can also work either way. So it'd be the same if it was the 7th root of 5x and then that whole thing to the 4th power. So be careful. It'll work either way. If we solve the radical, it just means you have to multiply by the same thing to get rid of it. Subtract 2, that's square root of 3p plus 7 is equal to 4. We square to get rid of the square root. We square over here. That's 3p plus 7 is equal to 16. That's 3p is equal to 9. And that's p is equal to 3. When we get down here with the 4/3, the 2/3, that kind of stuff, to get rid of that, you're going to raise to the reciprocal. So I'm going to raise this 2 to the 3/2 power. I'm going to raise this side to the 3/2 power. 2/3 times 3/2 makes 1. So I have t minus 3 over here. This would be 2 to the 3rd is 8, and the square root of 8 is 2 square root of 2. So it would be t is equal to 3 plus 2 square root of 2, maybe 2 minus the square root of 2 as well. But this should probably be enough to get you a good looking answer because, again, it should be multiple choice on something like this. If it's just under the square root sign, remember, add 1, take care of the stuff that's not under the square root first. That's square root of k minus 4 is equal to 6. We square it, that's k minus 4 equals 36. K is 40. Again, you got multiple choice on this. You can actually just take the numbers that it gives you for the answer, put them in for the variable, and see if it comes out by typing the whole thing in. That should get you through part 2.